In this video, we're going to talk about properties of inverse trigonometric functions. But for that, we need to answer this question very clearly. When can we cancel a trigonometric function and its inverse? In the previous video, we saw that for this angle 3 pi by 5, sine inverse sine of 3 pi by 5, that's equal to 2 pi by 5. Tan inverse tan of 3 pi by 5, that's equal to minus 2 pi by 5. And cos inverse of cos 3 pi by 5, that's equal to 3 pi by 5. Now 3 pi by 5 lies outside the principal value branch for sine inverse, outside the branch for tan inverse, but inside the branch for cos inverse. For these two, the branch is fourth and first quadrant, and for cos inverse, it's first and second quadrant. And because this angle was inside the principal value branch for cos inverse, we could cancel cos inverse and cos and get to 3 pi by 5. We could not do that for these two. So let's write this down. We can cancel the inverse function and the trigonometric function if this angle lies inside the principal value branch for this inverse function. This works for sine inverse, it works for all inverse functions. And it also works in reverse as well. Here we have to be careful about the range. This theta should be in the principal value branch. And here we have to be careful about the domain. This x should be part of the domain of sine inverse. For example, we can't have x as 50 here. Sine inverse can only take values from -1 and 1. If that's the case, we can cancel sine and sine inverse and write just x. This works for all 6 functions. And because it's important when we're cancelling these, let's recall what the domain and range for these functions are. So the domain and range for these 6 inverse functions are as follows. Let's summarize this using an example. Sine inverse sine of an angle is same as that angle if this angle is from this range minus pi by 2 to pi by 2. And it's not the case if it's not in this range. This is an example where it's not in this range. So here we have 3 pi by 5, but the answer comes out to be 2 pi by 5. So we can't cancel here. Now let's apply what we have learned on some properties of inverse trigonometric functions. Here's an expression. Sine inverse 2x square root of 1 minus x square. Let's try to simplify this. How do we do this? We have sine inverse of something. We want this to look like sine of some angle. Then we can cancel sine inverse and sine. This is 2 times x times root of 1 minus x square. If we substitute x as sine theta, this becomes 2 times sine theta times square root of 1 minus sine square, that's cos square, and we're taking the root. So this becomes 2 times sine theta times cos theta. That's actually sine 2 theta. So this becomes interesting. This becomes sine of an angle. So if we're substituting x as sine theta, we can say that theta is equal to sine inverse of x. Let's keep this in mind when we're substituting. So this becomes sine inverse 2 times x is sine theta. So this becomes 2 times sine theta root of 1 minus sine square theta. This is 2 sine theta cos theta. And here we can apply an identity. 2 sine theta cos theta is sine 2 theta. So now we have sine inverse of sine of 2 theta. And we can cancel these two and write this as 2 theta. But can we always do that? No. We can only do this when 2 theta lies in the principal value branch of sine inverse. And what's that branch? That's the fourth quadrant and the first quadrant. This is minus pi by 2 to pi by 2. So we can only cancel this when 2 theta belongs to this set minus pi by 2 to pi by 2. We can divide by 2 and say that theta belongs to this set minus pi by 4 to pi by 4. Dividing this by 2, we get minus pi by 4 to pi by 4. Now when theta is in this range, minus pi by 4 to pi by 4, where is x? Now x is sine theta, so x belongs to this set, sine of minus pi by 4 to sine of pi by 4. Sine minus pi by 4 is minus 1 by root 2 and sine pi by 4 is 1 by root 2. So x belongs to this set, minus 1 by root 2 to 1 by root 2. This means we can only cancel this when x is in this range. If x is outside this range, this is not true. This does not work. So let's assume that x is in this range and cancel it and write an identity. Sine inverse 2x root 1 minus x square is equal to 2 theta. That's 2 times sine inverse x. This is an identity that we can use, but this will only work for x which is in this set minus 1 by root 2 to 1 by root 2. Let's see a few more identities. Sine inverse 2x root 1 minus x square, and here let's replace x with cos theta. Pause the video, see what you get. Also figure out for what values of x will that identity work. Okay, Let's do this together. If x is cos theta, this means theta is cos inverse of x. Replacing x with theta, we have sine inverse 2 cos theta root of 1 minus cos square theta. So this becomes 2 cos theta, and this becomes root of 1 minus cos square, that's sine square, so that's sine theta. It's still the same, this is still sine 2 theta. So what we have is sine inverse sine of 2 theta, which means it's still 2 theta. But here theta is different. In the previous case, theta was sine inverse x. In this case, it's cos inverse x. We can only move forward in this equation. We can only cancel sine inverse and sine if 2 theta lies in the principal value branch for sine inverse. What's the principal value branch for sine inverse? That's fourth and first quadrant. That's minus pi by 2 to pi by 2. So 2 theta lies in this set, minus pi by 2 to pi by 2. Dividing by 2. Theta again lies in this set, minus pi by 4 to pi by 4. So what happens to x? X belongs to this set, cos of minus pi by 4 to cos of pi by 4. Now cos minus pi by 4 is the same as cos pi by 4. That's 1 by root 2. So what's the range for x? That's not 1 by root 2 to 1 by root 2, because at x equals to 0, cos of 0 is 1. So the minimum value for x is 1 by root 2, but the maximum value is 1. So x is in this set 1 by root 2 to 1. So when x is in this set, when x is in this range, we can cancel these two and write this as 2 theta. So the identity that we have is sine inverse of 2x root 1 minus x square, that's equal to 2 times theta, which is 2 times cos inverse x. And this is true when x belongs to this set 1 by root 2 to 1. So when x is from minus 1 by root 2 to 1 by root 2, we have this expression equal to 2 sine inverse x. And when x is in this range, we have this equal to 2 cos inverse of x. Let's see a few more identities. Sine inverse 3x minus 4x cube. What should we replace x with? Pause the video, figure this out. Let's replace x with sine theta. Theta becomes sine inverse x, and this expression becomes sine inverse 3 sine theta minus 4 sine cube theta. This is sine of 3 theta. So we can cancel these two and write this as 3 theta. But can we always do that? No. We can only do this when 3 theta lies in the principal value branch of sine inverse. This means 3 theta belongs to this set minus pi by 2 to pi by 2, which means theta belongs to this set minus pi by 6 to pi by 6. And what happens to x when theta is in this range? X belongs to this set sine of minus pi by 6 to sine of pi by 6. Sine pi by 6 is half, sine minus pi by 6 is minus half. This means x is in this range minus half to half. So when x is in this range, minus half to half, we can write this expression as sine inverse 3x minus 4x cube, this as 3 theta, which means this is equal to 3 sine inverse x. So we can replace this with this when x belongs to minus half to half. One last property, cos inverse 4x cube minus 3x. Pause the video, give this a try. Let's replace x with cos theta. Here theta is cos inverse x. So this expression becomes cos inverse 4 cos cube theta minus 3 cos theta. This is cos of 3 theta. So we can cancel cos inverse and cos, and we can write this as 3 theta. But we can only do this when 3 theta lies in the principal value branch for cos inverse. And what's that? That's 0 to pi. So 3 theta belongs to 0 to pi, which means theta belongs to 0 to pi by 3, which means x belongs to cos of 0 to cos of pi by 3. Cos of 0 is 1, cos of pi by 3 is half. So this means the minimum value is half, maximum value is 1. So x belongs to half to 1. When x is in this range, we can write cos inverse 4x cube minus 3x as 3 times theta, which is 3 times cos inverse of x.